Hi, everybody. I'm Sam. I'm here from a company called Elide. We're a brand new startup. We work in the Kotlin space. And I'm going to tell you all about Elide today. This is a little bit of an informal presentation because things aren't working and because it's pretty early software. But we really want to get your guys' feedback because we're Kotlin developers ourselves. And what we're trying to do is simplify and make better the tooling story in Kotlin. And you've heard a lot about that at this conference this year, but we have a slightly different approach, which is everything is native. So let me show you. So we're going to talk about Elide. Very plain presentation. This is not the latest version. Okay. Sorry, guys. This is like... Oh, that's exactly why this is happening. Okay. So while this all figures itself out, I'll tell you guys a bit about what we do. So Kotlin as it exists is mostly JVM reliant, right? When you use Kotlin, you never actually use it directly. You're always using it through something else, like Gradle or Maven or Bazel or whatever it may be. And our theory is that Kotlin is great. It's a fantastic language, and most of its power is hidden behind these other tool chains that cause all sorts of user issues when you're trying to configure your build or just get something done. What you guys saw from the Kotlin toolchain stuff today is really cool. We're seeing them like combine it all into one tool, sort of edge away from Gradle, give us an alternative, but that's all still JVM based. And what that means is you're going to accept a lag as it starts up and warms up because it's a JIT-based runtime, right? Now that pattern isn't particularly good for tooling. Oftentimes for tooling, you want things to run fast. You want it to start up, shut down very fast, and just do its work. And that's what Elide is. So what we've done is, show of hands, actually, this might help. Who's heard of GraalVM? Anybody? Okay. So maybe some GraalVM fans who found us. That's cool. So we're based on GraalVM. And what we do is we take these JVM tools that you guys use every day, and we nativize them, right, through Native Image. And just doing that makes them much, much faster. So all at once, Elide is a built-in Kotlin compiler, Kotlin formatter, Java compiler, Java formatter. It can also build and run JavaScript, TypeScript, and Python. And it can do it all very, very fast. So all of these tools, we give you essentially two routes to use these. You can opt into our build style, which is a sort of Kotlin-like dialect, which is nice because Gradle is apparently getting rid of that. And then the other tool, or the other way of using it, is to just use it drop-in. And this is mostly what I'm going to show you today because we really don't want to like ask people to rewrite their builds. You guys have been asked to do that like 8 times, and so have we. So the idea here is that instead of Java C or Kotlin C, you're calling Elide Java C or Elide Kotlin C. And you pass it the same flags, the same inputs, you get the same outputs. It's just much faster. I am now installing territory because my computer is still updating, believe it or not. So that's really cool. I promise I was like literally using this computer 5 minutes ago. So while that happens, I could take some questions. Yes?
So like how do you natify it? It's like, how could it be that you're wrapping a tool, but now it's faster?
Sure, it's working now a little bit. The answer is we use a tool from GraalVM called Native Image. And Native Image accepts a JVM program in both your code and all of your dependencies in the class path. And it establishes a closed class world, is what they call it. And then they compile that entire thing ahead of time. So your JVM program actually becomes a native program. Same code, but now it's nativized almost as if it's pre-warmed in JIT mode, right? All right, now we have something of a laptop here. Yes, in fact, I think can I borrow your laptop? Yeah. All right. Which means we're going to do this on the fly on somebody else's machine. Okay. There we go.
Already open?
Yes, you've got our website open. Thank you. Have you installed it yet?
Not yet.
Okay.
But, look at this.
That's all right. Okay. So I'm going to go grab the install command here. Oops. We are like, yeah, this is the worst it's ever been. Okay, so now I should say Elide is free. We have an EAP version, so our structure is like IntelliJ. If you just download it like this and use it, you don't have to pay for a license. You do have to update it every 30 days in that mode, just like JetBrains EAP, because we're trying to get some bug reports so that we can fix this and make it better. If you want to opt out of that cycle, it's $15 one time. One time. So it's Windows licensing where when you pay for this, you own it forever. When we come out with a new version, if you want to buy it, if it's better, go ahead. But your old version is never going to stop working, right? And that's very important to us. Okay. Thank you. Your computer is working. So here we have Elide help, and it's going to show us just some of the commands that are built in, right? We can create a new project, get info about this project, run, serve, build, so on. And then we have some of these like Maven, KT format, Java format. These are tools that you can call directly. And those tools are exact copies of what you're used to. It's just native. So for instance, I can do Elide, Java C, help. Oh, this is a European keyword. Okay. And this shows me that it is Java 25.0.3. This is identical help output from what you'd see from Java C, right? Just native. And I'm going to have to be a little quick here with like, so let's, do you have Rust on your computer? Okay, that's fine. When mine boots, I'll do the benchmarks, but basically, here. Let's try to compile some code. Yes, we have, so the languages we support, by the way, Python, JavaScript, TypeScript, and Kotlin. I have to like watch what I'm typing here because I've never used a keyboard like this. Okay. That's okay. Not your fault. Oh, geez. There we go. You crazy Europeans. Well, we deserve it. There we go. Okay. So we're going to try it here on the fly. Let's see, Elide Kotlin C. And we're going to give it identical, like put it in the target directory for me, and sample.kt. Now, that is extremely fast. The Kotlin compiler normally from cold is at least a second, maybe 2 or 3 seconds to start. And that stays that fast, it turns out, up to about 10,000 classes. So it turns out native, when you're compiling Kotlin or Java and JVM, they converge because JVM has a fantastically talented JIT. And so when JVM is hot, it's much better than native, right? But actually marginally better than native. But if you compare those two, this is already hot most of the time. And so you're getting a gain most of the time when you would be in sort of like a warm, cold state. You're already warm, maybe not all the way hot, right? And lifting that for all of your interactions ends up providing a lot of your time back to you. So we've done this for Kotlin C, we've done this for KT format, and one of the benchmarks I have on my machine, which I'd love to run for you, is formatting like 10,000 files, right? Now, that one's really fast. You can see it. We've animated it. I'll play it for you as soon as my benchmark works. But it, like I said, it's identical to the regular Kotlin format. And particularly when you're like doing git hooks to check your syntax or something like that, that's when it makes no sense at all to call a JVM, right? Then you really want a native tool that you can just call KT format, pass it the files, and that's what we can do. Now, our KT format, by the way, 185x faster. We advertise 100 because like, who's counting at that point? But 185x faster is what you get when you're just parsing code and reformatting it. You don't really need a JVM and a JIT and all the observability that comes with Java, right? So I think I'll start taking questions. This is like a disastrous demo. So I'll start taking questions, try to get this up so that I can show you guys because that's the coolest thing to see here. And then we'll go from there. Yeah. Thank you for your laptop. Here. Thank you.
So, what was the most challenging part in getting GraalVM Native Image to accept the Kotlin compiler?
So we've recently open sourced all of those lessons because we think everybody's going to solve it eventually. The answer is that the Kotlin embedded compiler pulls in a lot of IntelliJ's infrastructure, the PSI and the other parts of IntelliJ that do parsing. And some of that is really reflective, right? And reflection is hard in native image. So we've had to tune some of that. We've had to carve out some code that's not relevant. So for instance, we don't support JS or KMP yet. And so those parts are carved out of the compiler to make it faster and smaller. But overall, any JVM program can be made into a native image if you try hard enough.
Even IntelliJ?
Let's not get crazy. Let's also not bring up Gradle, because there's a certain amount of reflection that just makes no sense in native image, you know. Mm-hmm.
I want to say great job improvising right here. It's like a just-in-time demo.
Thank you. Should be an AOT demo. But
I was kind of curious about some of the utility that this might have, say, for like CI, being able to get your pipeline times down, if you could elaborate on that.
It's night and day. It's just night and day, especially in like a GitHub action runner where you have very little CPU, no time to start up and optimize, right? Often in concurrency limited circumstances, your build threads are fighting with the compiler threads. The compiler threads that are optimizing your JVM build code, right, are also running on the CPU, and so they're fighting, and that's wasting time when you should just be compiling code. In fact, oftentimes for tooling, it may end up being more performant to just run in interpreted mode and turn off the JIT, because then you don't have that sort of contention between the utility threads and your actual threads. So, sorry, does that answer your question? Yeah. Okay, cool. Yeah.
I have a question regarding running it in like pipelines and stuff. Is there a plan to support WASM as a target? Because then you would be able to use like WASM runners in Kubernetes and stuff?
So when you say as a target, do you mean for us running on WASM or for your apps running on WASM?
For Elide running on WASM, so that you can like either run it in the browser or run it in like a WASM runner in Kubernetes.
So the answer is yes, kind of. And here's what I mean. Native Image is adding a WASM target, which is cool because that means we can take any JVM program and compile it to WebAssembly. That today is meant for browsers. We're doing some experimental work with Oracle to make that WASI compatible, which would move it to the server and Kubernetes and Fastly and all the other sort of WASM ecosystem out there. Graal, by the way, is its own WASM runtime. They have Graal WASM, I think it's called. It's pretty competitive. And so WASM is a guest language that we can support too. Cool. Any other questions? Okay. Thank you for suffering through my demo, guys. Yeah.